All right. Well, thanks very much for showing up, folks. By now you've had time to read the title of the talk, and also now this is about some of the issues to do with the development of electric vertical takeoff aircraft. And now you'll see here, this is a lot about. I adapted this from a talk that we do to talk about what goes on in my company, Continuum Dynamics. And you'll see kind of why that weaves in today. But we're fortunate too. We'll have a kind of a 1-2 punch on electric aircraft because Gaylord will be following me up with some other material that'll nicely complement what I'm talking about here. And one thing I'll say right up front too is that the kind of stuff I'm going to be talking about today is, as you'll see, this is not really kind of an under the hood power systems technology take on electric aviation. This is all about a lot of the design issues of the vehicles and some of the associated, although there is some crossover there. So you'll see about that flavor of it here shortly. But anyhow, you see here up front on the title slide a couple of the aircraft that are out there of the many different configurations that are under study right now. And so there's ought to be a real blossoming of novel vertical takeoff aircraft concepts in the last about 7, 8, 9 years. And I'll narrate a little bit of that as it goes along and are part of it here. So anyhow, what we're going to talk about is what people often call the eVTOL revolution. Basically, the fact that you're getting new potential markets for using and building vertical flight aircraft, both for passenger transport and for cargo. Now, things that make it possible, you got electric motor technologies advancing, battery technology, ability to control the flight of these aircraft, structures, configurations you can do, and also people's different mindsets about what they want to do with aircraft. The thing is, there's major challenges ahead and already being faced by the people trying to develop and field these aircraft, and also in getting the operational story together about how they're going to be used. So anyhow, I'll present here kind of the story of a bit about what we have been doing as a way into describing what some of the issues are about aircraft development and analysis here. And so there's also, you see the term here, and AAM, Advanced Air Mobility, was kind of been the umbrella term that's been applied to this whole new domain of different ways and vehicle concepts for operating these kind of aircraft. But anyhow, and just a basic take, what is eVTOL, electric vertical takeoff and landing, and why is it coming up now? So a number of things are coming to the fore. The ability to use electric propulsion, which has therefore zero emissions from the aircraft. Of course, electricity comes from somewhere, so there's a question about where that comes from. But also you can now distribute propulsion over the aircraft with smaller, more compact electric motors. And over there on the right are kind of two of, shall we say, the signature types of aircraft that you may have seen. A fixed wing aircraft, the X-57, which is a NASA experimental project, which has propellers distributed across the wingspan, all driven by electric motors. And then down at the bottom is a vertical takeoff aircraft, probably one of the first that got into this domain, is Volocopter, which an aircraft from Germany that has about, I believe, 18 different small electric-driven motors around the rotor disc. So these are kind of like the, if you will, sort of the marquee entrance in this area that kind of really bring to life the idea of distributed propulsion. But also you get, with that, you get redundancy. A lot of different rotors lifting the aircraft or propelling the aircraft. And also some elements of simplicity. You have knocked down the part count in many respects on the components here. And I'll talk to that a little bit later. So those are some of the things that have gone on that have driven people in vehicle control into this domain. But what's the vision for the application? There's a lot of different takes on this, but I brought over there on the right the cover of the white paper that folks at Uber wrote back in 2016 that talked about the concept of urban air mobility. And their vision, if you went to or heard about some of the so-called Uber Elevate summits that they ran for a couple of years to talk about the application of these vehicles, is all about the issue of you got growing urban areas that are getting congested. How are you going to get around? And so the idea of using air transport to do that and complement, and obviously they had it in mind to complement their road vehicle system, obviously, but that's one overall vision. Now, basically, too, if you look at this as like air taxis or flying cars, so to speak, it's a new dimension of personal mobility, the way to get around. And also, there's major opportunities in moving cargo and material that kind of can fit into the logistics scenario that we've all been experiencing. Different parts, ways to deal with the Amazon pipeline and others. So a lot of people are looking at many different roles for these aircraft and what they might be able to do. So anyhow, how do we figure this? And I say we is I kind of put this in here. This is shameless self-promotion, but also because we are a local company. I mean, I work for Continuum Dynamics. We're about a 24-person outfit. We're actually just down by the high school. And we've been there. The company's been in business since 79, but we've been in Ewing since 2000. And we got 24 folks down there. About 2/3 of us are engineers of various types. And we work on a lot of different areas that touch on these fields. Air vehicle design, computational fluid modeling, flight simulation, and we write software that we license out to people to help them work on a lot of different aircraft and the eVTOLs in particular. Now, we work for just about anybody that deals with air vehicles in the government and a lot of different major companies, but a lot of our activity in the last 7, 8 years has been with folks working on the eVTOL aircraft. And we've got 20 plus customers in that area that we support. So we've had the opportunity to have our nose under the tent on a lot of the issues they're trying to deal with. So that's been a very interesting development, put it that way. And that's me over there, my smiling face. And I've been around in the company since the late 80s. So anyhow, what do we do over there? And this kind of, and again, it's about us, but also about what the issues are we're trying to deal with. We do a lot of aerodynamic modeling work. And these is some animations of air vehicle models that we use. And it's a wide range of them, as you can see. You got a DJI Phantom over there on the left. You have the V-22, the US Navy tilt rotor in the middle. And then there's a hypothetical eVTOL aircraft, a winged rotor compound that NASA put out as kind of a generic placeholder for a so-called lift plus cruise aircraft. And so we do a lot of modeling work for folks who are looking at a really wide range of air vehicles. So what's the relevance to eVTOLs? Well, you got a lot of complex configurations. It happens, the software that we run lets you know all the different parts of the analysis, lots of rotors, the fuselage, pushing rotors, lifting rotors, lets them all communicate with each other. And those colored lines there, by the by, what are all those colored lines? Those are actually little tracers. For those of you who've seen airplanes flying overhead, you see contrails or some forming behind the aircraft, but usually they're markers for where the tip vortices coming off the wing are. And when you have a rotating wing, you essentially have a similar structure coming off the tip. And those vortices that go around and interact drive an awful lot of what happens with the performance on the rotor, the noise they make, the vibration they experience. And this is like paint in the air where those vortices are present. So that's what all these colored lines are here. And they essentially say this is, and you can kind of get the idea there's a lot of interaction between everything going on. It's not some really nice, clean situation. So that actually is one reason why a lot of the tools have been using have been pretty popular, because we let people capture that. Now, this is kind of one level of modeling. There's another sort of, and there's a little bit of an artificial distinction, but when you start to deal with some higher level, more resolved types of flows, what people tend to refer to as CFD, the generic term, where you're looking at capturing now some more things about skin friction over the aircraft or other higher level of interaction in the fluid modeling going on. And so we have a bunch of different complementary tools that address that as well. But again, the theme, what's the theme here? You got a lot of different types of vehicles to deal with. And we cross the whole boundary from fixed wing aircraft like F-18s, like in the Top Gun movie recently, over to all sorts of compound rotors, multiple rotor systems, propelling rotors, and so on. So those are out there supporting people as well. Other things that we do, and let me go over here and get this here. This is, if we get this going here, will it go on a Mac? Yeah, this is where I'm afraid we got a problem here. You're not going to get drat. Well, you have to come up later on and see this on my laptop, because I didn't know I'd be on a Mac here today. This actually is a video of a helicopter landing on a ship, and essentially one of the things that we do is plug some of these models into the flight simulation, so people can have kind of the aerodynamic modeling we have that goes on when you've got helicopters or any other kind of vehicle going in and doing like a landing situation. And there's a lot of different messy aerodynamics that go on when you're like, this is a case actually that led us into a lot of relevant work, because you're trying to bring a helicopter down the back of a ship. You got all the burbling air coming off the ship. It's a lot like what you're going to encounter in one of these eVTOL aircraft if you're flying around the city. And I'll come back to that a little later. So basically, we use all the software for a lot of different things to help people with engineering, coming up with safe procedures, and also pilot training. You get people in the loop so the pilot can actually, have that, have that experience of what's going on. Similar theme here. I just put another one, and this again is another non-functional movie, sadly, because again, if I was running on a Windows machine, you'd see it work, but I can actually bring it up on my laptop a little later. But this is actually two V-22s flying in formation a couple of years ago, and I just noticed that we're not quite getting the whole screen up there on there. So my apologies too. I don't think we'll lose too much off the right, but I'll try to keep that in mind. Those are two V-22s that were in formation, and they kind of ran into each other's wake and had an interesting, not quite flip on the back experience. But this is a kind of a placeholder for the issue of what happens when you have a lot of airplanes flying around in very close proximity. If you imagine a future with a lot of different vehicles flying around in dense environments, this sort of thing you can run into. So this is just kind of the part of the tool set that we try to be able to make available to people to look at issues of this kind. So one of the things too we try to bring to bear to help folks out is just some experience working in this area. Now, if you go online, you can find out a couple different places this big chart, which is over there, and it's kind of tongue-in-cheek referred to as the VTOL Wheel of Misfortune. It's essentially kind of a diagram of all the different vertical takeoff aircraft that have been tried with jets and tilting wings and rotors and propellers ever since about the mid-1950s. And there's only 3 or 4 of them that ever really got into operational service, which kind of says that getting vehicles that can kind of have vertical takeoff and then transition over to high-speed flight and operate in the way we imagine them operating is not easy to do. And so you've got helicopters right now that have succeeded. You got tilt rotor aircraft, and a few jet vertical takeoff aircraft, but not much else. So some of the technology we've got that coming into the eVTOL domain is going to help some of this, solve some of these problems, but not all of them. So it's one of the things we try to both help people out with some of the lessons learned from all that experience there. So yeah, one comment too, I just do try to note, I've shown you a lot of computer pictures, but I'll just note too, we've worked on a lot of real aircraft, and some of the hardware we've helped design is out there on real vehicles. So everything from one of the first kind of generally used unmanned air vehicles, the Schiebel S-100, that's a company out of Austria. They got a widely used, it's about a 500-pound helicopter out there, one of the first kind of remote UAVs that was widely used, to designing rotor blades with help of some folks who put rotor blades on a lot of different S-61 helicopters, and that includes one of the presidential helicopter squadrons. So that's out there. We've helped people do that. And then if you've seen a lot of the film of people water bombing stuff in the California fires in recent years, the air crane over there, which is an aircraft that's used pretty frequently there, we help them design the new rotor blades. So some of the stuff that we do actually does get out there in the real world. Which again, we're trying to help people acquire some of that legacy of experience. So anyhow, back to this. Basically, what is the whole picture going on here? And these are just a couple, and I think Gaylord would go into a little more of this too. There's a lot of different configurations out there. Kind of a litany here. The guy in the middle there, the Joby folks, are probably one of the farthest along with the folks at Archer over on the right, coming not far behind. But there's a lot of different. They're startups from the U.S. You've got the Eve, which is a subsidiary of Embraer, the Brazilian aircraft company. They've got their aircraft. Vertical is a UK company, a startup as well. Volocopters from Germany, and Lilium, I think, is operating out of, Slovenia, if I'm not mistaken. And so a lot of different vehicles. Germany?
Sure.
Thank you. I was trying to remember. No, it's not. Yeah, it's Pipistrel, who's out of Slovenia, I think. That's the so a lot of different folks, a lot of different pedigree, but a lot of different features in common in a sense. There's kind of three major divisions of vehicles. There's vehicles that combine wings and rotors, so-called lift plus cruise. There's people who tilt the rotor systems. That's kind of a vectored thrust concept. And then there's vehicles that are so-called multicopters. They're kind of like conventional helicopters, but there's lots of different rotors. So there's a few other variations on that theme, but those are kind of the three broad, big, big categories. So a lot of things going on. Again, even more vehicles out there. Folks at Elroy are out in California. They're actually focusing on the cargo mission. So it may be rather smart to do that. Folks at Beta up in Vermont, they have some aircraft flying around now. And then a lot of other big companies, Honda, which is getting into this business, and Supernal actually is a spinoff of Hyundai. So they actually have, some of the Bigfoot companies are involved there. And then there's people who are looking, like Jaunt is an outfit that's looking more at a more conventional helicopter-ish looking aircraft. And then finally, Overair is a spinoff of a company that's building tilt rotor aircraft out in California. So a lot of entrants, a lot of people working in this area. So but they all have kind of the same kind of list of issues they got to deal with. That's what I'll try to address here in the next couple of minutes, and the kind of some ideas about the issues you got to deal with. And I'll hit different ones at different depth, and I'll try to be honest about what we know about what we only sort of have at arm's length. There's a lot of different issues you got to worry with. What's going on with your propulsion system? What are you doing about safety for your aircraft? Obviously, a preeminent concern. Well, how is the issue of autonomy going to work out? What role does that need to play? What kind of experience you're going to have in terms of ride quality? Because it's got to be, it's something. For depending on your customer base, that could be a very big issue. What's noise going to be like? What issues are you going to deal with? What are the operational issues you run into when you're trying to actually flow these into operations? Yeah, you can have so-called vertiports. Where are they going to operate? What's going to happen? What do you need to worry about? And how are you going to convince the FAA that you've dealt with all these issues above and that they're safe to fly? So very quick take on all those issues, more or less in order. Propulsion-wise, a lot of the systems that have gotten air vehicles gotten going together so far have assumed you're working on battery power. Now, the challenge there is that given the kind of current power to weight ratio for batteries, it's really hard to see how you do anything other than relatively short range missions with straight battery power, because the weight is everything in aviation. It's even more so in vertical takeoff aircraft. And so if you've got not a great ratio of weight to power, that's going to limit you. And so for short range, urban area type missions, you probably have some good options. But after that, it really starts to get to be a challenge. You have to start thinking about a hybrid, or the other option that people are looking at more recently and with greater emphasis is hydrogen-powered fuel cell aircraft, using fuel cells to drive the electric motors. And that's actually getting a lot more traction in recent years. And there's been some Zero Avia's outfit over in Europe that's demonstrated some fixed-wing aircraft going up on straight hydrogen power. And actually, there's two companies we're working with that are looking at vertical lift aircraft. They actually have some vehicles in the air right now that are, the Alakai folks there in Massachusetts, and then the Piasecki folks are down in Pennsylvania, right near the Philly airport. So they've got a couple of those vehicles that are just now getting off the ground, literally. But there you've got other challenges. Hydrogen is not very dense, so the fuel tanks get pretty big. That's a problem. And also just having a steady supply of fuel. That's something that's just being developed as we go here. Sure.
I was going to say, you're coming to the banquet.
Don't know. I got to go home afterwards. So I want
to your speaker certificate. I know.
Lovely.
To get it.
Very good. Okay, thank you.
It's right at the front desk.
Wonderful. Thanks very much. We have our other speaker here too.
Sure.
Okay, no, it's great. Okay, thank you. All right. See, safety issues. I mean, we're all accustomed to the essentially, what's the last time we heard of a major scheduled airline crash? Not too many. So obviously you got a very high bar when you're talking about possibly having hundreds or thousands of these air vehicles around, and they got to be understood to be safe. So really the issue is you've got a lot of the vehicles have a lot of ostensible redundancy to a lot of different rotors involved. There's also a lot of different parts. How much, what happens if any one or more of them fail? What are the sizing of your various devices that kind of give you protection against any accidents? One challenge is, people are sometimes thinking about relying on parachutes for recovery if you have a problem. If you aren't above about 1,000 feet, it's kind of hard to see that working. And talking about deploying a parachute and not having a bad result in a cityscape is kind of hard. It's sometimes kind of hard to see. So it's all about how much redundancy, auxiliary motors, batteries, what do you got to build in to kind of be safe while you're operating? So that's the other thing too, is that helicopters, for all their flaws, they got one big rotor, and they actually have a pretty easy way to, if you lose power, you can actually still have a controlled glide to a landing. And because of the way you load up a lot of these smaller rotor systems, that's not so obvious you can do that. So that auto rotation capability where you can glide in a controlled way to a landing is not so easily done in a lot of these systems. Autonomy is now, I'll freely say this is not something that we do a lot of in at our company. I just make one observation. I think it's just kind of a motherhood statement that you're going to need to have autonomous flight capability for really large scale use. And over there is just one chart I just grabbed off the internet. It's a 2016 plot of, they were talking about the blue curve is the dropping number of private pilots, and the red curve is a slowly increasing number of airline pilots. But the basic number is you got about 150,000 each as of 5 or 6 years ago. So you got 300,000 pilots in a country of 300 million people. So obviously, and I note too, the biggest number of pilots that we ever had in the United States was in 1948. So it's kind of hard to see if you're talking about thousands of vehicles, you may not have that or really wide pervasive influence. You probably are going to have to rely on having some autonomous vehicles. So that obviously is both a challenge and an opportunity. It's a pretty high bar to do, but also in a way it may be a little bit easier than what we've seen people deal with self-driving cars. There's a lot of things wrong with aviation or challenging about aviation, but you got less people to run into. So I think we'll probably see this first with some automated aircraft going in cargo runs, but obviously if you're going to do passenger travel, that's going to be something that's a major challenge to overcome. And that's actually moving to center stage in the minds of a lot of people in the field right now. No, ride quality. No, you want to not have people be motion sick or have a rough ride here. One of the things, again, back upper right there, all those wonderful colored lines. You got all the different wakes and disturbances and different rotors when you're flying this aircraft running into each other. Makes a lot of vibration. So you got to figure out a way to manage that, because it drives a lot of things about how well you perform, but also how much vibration you get, and also the noise you make. Now, one of the things that's nice about some of the eVTOL aircraft, and maybe you can see on the right there, they have, a lot of the vehicles have lifting rotors that fly along, and they have relatively clean look, relatively low part count as compared to a conventional helicopter rotor down below. So a lot of gear going on there. The thing is, I always ask people, do you think people want to build helicopter hubs that way? Answer, they don't. They kind of have to, in order to keep the loads that show up on the rotor from getting back into the aircraft, and also to control the rotor in a way that it's easy to fly. And so I think that people, and we know, are already finding that some of these, the vision there, or at least the paradigm of having that kind of nice, simple, clean, like a propeller, like on an airplane flying sideways through the air, doesn't work very well. You get a lot of vibration in the aircraft, and you need to kind of find a way to get around that. And so that's going to be another thing that's going to make people have to kind of adjust their course as they put things together. Noise is going to be a big issue. The good thing is that a lot of the aircraft people out there already designing these vehicles now are paying attention to that, and they actually have been able to develop some concepts where the rotors turn relatively slowly, and that helps knock the noise down. And that's a good thing. But also, again, all these different disturbed wakes of the rotors interacting with each other creates new sources of noise. So that's now, you kind of push down one thing, and it's like whack-a-mole. You push down one noise source, you get another springing up. You have a nice, electric motors themselves are quiet, which is a good thing. So there's also some folks are finding the stuff you need to do to cool the electric motors are not necessarily quiet. So again, it's there's progress being made in this, but having this be covered is going to be essential if you're going to have things flying around. I mean, you still, if you watch the news, you see people even in Manhattan complaining about the heliports. If you're in Manhattan, for heaven's sake, and people don't want to have the noise of helicopters flying around. Now, if you picture having a lot of different vehicles zipping around, they're going to have to be pretty quiet for people to be okay with them. Another thing too is people used to, the first term people used when they were talking about these aircraft was the idea of having urban air mobility. It's because originally the focus was on city operations. The problem is that with urban air mobility, to do that, you need to deal with what I call urban air. You got building, you got dense cityscapes. Like down there on the lower right is a computational model. All that blue toothpaste you see between the little buildings there is essentially kind of a painted air depiction of all the burbles coming off of large buildings. And if you're flying around in urban canyons, you're going to run into a lot of different amounts of disturbed air. And that actually is kind of one of the lessons we took away from doing a lot of work on shipboard landings, is that makes life very interesting flying around. So that's so basically people are developing a bunch of different ways to deal with that. But again, it's going to be another challenge trying to figure out how you're going to, handle yourself to get to the ideal place, which was that vision up there on the right from Uber of having some, nice looking vertiport in a urban cityscape where you're operating. And then the whole issue of the FAA, you got to keep them happy because they're the gatekeeper for everything. Now, so basically certifying these aircraft is going to be a fairly big lift. And I just note the following thing. Some of you who maybe follow the aviation biz will be aware of a tilt rotor vehicle. Actually, it's built down in the North Philly airport, not far from us. The folks at Augusta Westland are building that. They bought that design from Bell Helicopter some years back, and it's hoping to go into service as being a civil tilt rotor aircraft, kind of like a smaller version of the V-22, which the Navy flies. And it's built to be kind of executive transport. That aircraft has been in development in the process of getting certified. It's now going on 20 years. And so it's going to be an interesting gulf because as of last spring, the FAA decided, well, we're going to apply to these eVTOL aircraft the same regulatory framework that we're applying to the 609. Okay, so a lot of the companies are getting themselves tooled up to deal with that, but that's going to be a big jump. So basically, because these are all very new aircraft, and the FAA says, we got to make sure people are safe, and you understand that, but it's just going to be that could be some significant speed bumps. And then one thing they did say is that aircraft like the one over there, the Jaunt guy that has like one big rotor, if they look more like a helicopter, they'll be treated like a helicopter. So that makes their life a little bit easier because helicopters are a little more familiar in terms of getting through all the regulations. But that's still going to be a pretty big bump, which is why people who focus on that will be among those who do well in this area. So anyhow, the wrap up here, as you can see, the vehicles themselves are coming along pretty well. They got design challenges. They're getting up in the air. You're seeing them in the news. You're seeing them online. There's a lot of potential here, but as you kind of heard, my laundry list of challenges that you could run into here. And so one of the things that we're trying to help folks with is kind of bring the right kind of lessons learned from everything that's gone before into their design process. And also, so the people who can kind of deal with the laundry list I made, and I think those 5 or 6 things I noted are probably the big ones, will probably be maybe the ones you can watch and will have success in I think what is still properly called an eVTOL revolution. So anyhow, that was about 30 minutes, but anyhow, that I'll stop there and just glad to take any questions that you folks have on this or any other tangential questions. Thank you. Sir.
What is or eVTOL in general? Other than that, why would the designs of
You can, a couple things. It is with the idea of distributed propulsion helps basically for, you can get a number of, you do have, it's one of the ways you can buy a certain amount of redundancy in the lifting systems. You can also create some flow over various aircraft components that you can't really do with one single rotor. You have the ability to fine tune the flight control to an extent that is not always easy to accomplish with a single rotor helicopter. And also the fact it's with and also there's the weight advantages in terms of the ability to have a lower part count because of the of electric motors too is another advantage. So but you get certain advantages and you give up certain things. So that's part of the trade here. So, sir. Yeah, it would. But fundamentally, that's it. See, fundamentally, that's kind of the issue, getting down into the weeds of things. Why the FAA ultimately decided to go with the categorization they did is that a lot of the training that would have to work for these aircraft is going to be a lot more like what people have to do to learn to fly tilt rotors. So it's not the same because you got a bunch of different interacting components. And so that's why they chose to go with that that categorization. Just to kind of, so yeah, there is, because you have many different, just because the control systems are going to be different, and it's just trying to figure out what is a way to make it accessible to people through regular pilot training. There's another sort of background challenge they have to deal with. Yes, sir, Caleb. Yeah.
one question that like comes up a lot, and my discussion is that this morning with my friend, are you going to keep these things from hitting each other in the sky?
Now, traffic, well, basically, yeah, well, that's fundamentally traffic control is just going to be it's just a fundamental issue. I mean, we're only in the dimension that we on the part of it where you're saying how hard is it for like the average aircraft to deal with some disturbance you might run into. In other words, when do you run out of control in the aircraft to make it hard to fly? We don't actually do the traffic part of it about saying, okay, how are you going to get people through a dense airspace? That gets over into people who are like everybody who's doing air traffic control for current airports, now trying to figure out how do we now shoehorn that knowledge base into something that's going to be a hybrid between the the current air traffic control and what happens on the highways. You can kind of imagine the challenges there. So that's I imagine this is not a speculation. I imagine what's going to happen is they're eventually going to have something like you do now. You're going to have essentially flyways, pre-described paths people are supposed to take, and there'll only be so many people in a certain flyway at a certain time. That's just a guess. So, but I know it's a major concern. Sir.
There were 2 movies in the late 70s made after Star Wars.
Yep.
The Empire Strikes Back.
Yeah.
Some of those movies depicted flyways
Yeah.
They did aircraft in a large line going on a carefully defined.
Yeah.
I would think if you enter the flyway that the whole economy should.
Yeah.
That you want to do it under your control.
Mhm.
So you have the spaces.
Yeah.
Issues like clear air turbulence.
Yeah.
Things that people are event now.
Mhm.
You had this fluid dynamic models there where you showed the amount of turbulence.
Yep.
We have that on the oceans with boats.
Sure.
For instance, wake problems with small boats and so on. The thing is, we can see those.
Yeah.
Now, the problem here is we can't visually see
Mhm.
the turbulence wake
Mhm.
that's coming up. We had a issue, I think, last week over the Black Sea. There was a Russian aircraft that
Yeah.
actually dumped fuel on one of our drones.
Sure.
And that's made the news. Now our Air Force has released footage of that.
Right.
It's interesting that these somewhat look related to drones, but they're not really, you wouldn't call these drones.
Well, actually, I would. The point you're making, that's why I wish I can show you the animation here. In general, this issue here, this is two V-22 aircraft, is exactly that question. Because these are two guys who are flying in formation. The guy behind there, and when you see the animation, you'll see he flew into the tip vortex of the one in front there, the orange one, and had a really big roll angle develop, a big disturbance. And so the thing is, now it's interesting you mentioned about painting the air, because we actually got involved when they went to look for how do we fly the aircraft in formation so that doesn't happen.
Right.
We actually got involved with people, because when they go up there to go look for the way where you can fly safely, they got to hunt around and find out where it's safe. So the point is, the simulations that we developed actually were used by the Navy folks to train beforehand to go to see where to fly to find the bad spots to stay away from. So, so depending how close you get, you may have to have not only, well, first there's, in terms of what you said about computer control, you're going to have the easy way, quote unquote, is rules of thumb, so that, when you're far enough apart, the wake's dissipated enough or it's gone down enough, because they do tend to descend, so that you're safe, which is exactly what happens with airports now. It's how they space things out. That's why they're all about 3 miles apart, 3, 4, 5 miles apart. Or you have, maybe if you really feel like you know what you're doing, you can, and you feel confident of what the disturbances are, you can pull them up closer. Or sometimes too, what you do as well is that maybe you've got instruments on the air vehicles that are picking up, oh, it's getting a little too rough, let's now space them out. Again, it all sort of folds back to the issue of, if there's not only there's onboard sensing, but can you have and can you trust a big system that's going to slot everybody around and keep them in safe distances. So there's a lot of levers to this, where what we do kind of overlaps with what Gaylord asked about, which is about the global flight control issue.
Yes. The carrier operations, where we're landing, taking up out of aircraft off the carrier.
Yeah.
Is we've learned a lot about how we can get these enormous airplanes off and around.
Yeah,
That's the problem. The problem with the air is that sometimes you got a prop spinning around, all of a sudden it's vacuum.
Yeah.
There's no air.
Yeah.
So you drop, and then all of a sudden you hit air. You get all these G forces. So
Sure.
they make a pretty rough ride.
No, those, I mean, if it's actually had one or two not too bad experiences of running into a disturbance on approach to an airport, and that makes when you get all of a sudden, usually it shows up as a quick roll on the aircraft, all of a sudden, bang, there you go, it gets a little bit interesting. You say, yeah, we just hit something. So it's as you get things jammed up, if we're going to get to this vision of the Star Wars vision, you're going to have some way to cope with that. So,
Those there's no turbines. It's all pumps. So
well, it depends. I mean, here there are quite often, there are a lot of these vehicles are running off electric motors, but sometimes they have turbine engines that are running a generator to generate electricity too. That's a hybrid system. So you're not doing, you don't do jet propulsion ordinarily. You're using some other kind of shaft-driven rotor system.
Back in the B-36, the late 40s, they had the atomic aircraft experiment.
Oh yeah, there we go. Yeah, it was
They
entertaining.
really tried very, very hard to make atomic aircraft, and at that point, it was a complete failure. But now, in this era where we have artillery shells, it begs the question: is there an application here?
I think you're going to find it real hard, having looked at airborne nuclear plants a while ago. You find it real hard to make that weight work. That's the problem. It's great for long duration, big aircraft like B-36, but smaller systems, that's going to be real tough. So but anyhow, let me take one other question over here.
Yeah, just a question about safety.
Yeah.
Because you mentioned how some of that designs that had similar helicopters don't go. I'm assuming the ones with the public houses fly feature.
Exactly. That's one of the pros of it. If you've got a wing system, then you can have the same kind of benefits that a fixed wing aircraft has, where you can say, okay, I'm not relying on vertical lift to let me land. I now have the option to go and just find a runway, assuming you've got a runway.
So, aside from just idea of power, what are these nature safety for electric? So what's the difference between eVTOL and a VTOL when it comes to safety? Like, what's something that's unique?
It all just, well, there's just you could say that there's different failure modes you can run into each. I mean, I think one of the advantages of an electric aircraft is you got smaller part count, so there's fewer things to go wrong. So that's actually not a bad thing. I mean, there are some things. I mean, as I said, it's a testament to how valuable vertical flight is that you have helicopters. Because if you look at what you have to do to make that system fly, I mean, people joke about it being 10,000 parts flying in formation, but it's fundamentally true. And so you have a very complex, tried and true, you have a very tried system. You know where a lot of the problems are. So so if you go electric motors, fewer things to go wrong. In many implementations here, you do have the distributed propulsion, so you have some more redundancy. But you got to think carefully about how you have to size things, even if they are redundant. How many can you afford to lose, and how much do you have to kind of over-design the aircraft in order to absorb a certain number of failures? So now, and we all see that tabletop quadcopters. So why you're not seeing, on the whole, too many pure helicopter quadcopters? They're probably going to a few more rotor systems. A couple of reasons behind that. So I think hopefully I answered your question in there. Very good. So, and I think Gaylord might have more to say about that afterwards, because I had a sneak peek at some of his issues later. But I think I'm at the end of my time. Any last question? Yeah, but I have to get my laptop out, and I apologize too. This is one of these PC to Mac interface problems that the videos don't play when you cross over from PC. Anyhow, thanks again for your attention, folks.